discussion. Now, in my discussion, I'm going to quickly go through mangroves. We shall discuss why do we use Venus and how, in line with the objectives of the studies and the questions that I want addressed. We are going to look at the study area, which at this moment might not be very, very clear, but you can see some mangroves, and we are going to discuss some of the expected results. Now, mangroves are plants that are found in brackish water. That is water that are plants that grow in brackish environment. That is an environment that has water that is neither salty nor fresh. It's in between. At the moment, we have at least 6 to 8 million hectares of mangroves in the world, of which 3 million are found in Africa. There are so many species of mangroves. At my study area, we have 10 species, but I'm only going to talk about 4 of them to illustrate the concept that we use in our study. Now, in this corner, you see one of the species called Rosifora moconata. What identifies it from the others is that it has some sort of medium height, and it has some distinct walking roots. You notice that the roots look like some feet. Now, then you also have Cereopstada, which has broad leaves and grows very tall. You have Avicennia marina, which is normally grayish. And then we also have Sonerita alba, which has some sort of needle-like roots, as you can notice in the picture. The importance of mangroves is that they can be used for timber, for charcoal. As you can see, the lady has collected some timber to make some charcoal. It's important for tourism. They are also useful for construction of houses. Mangroves are reducing at the moment because, first of all, sometimes you find scenarios whereby there is too much salt water, perhaps because the fresh water going to the sea has been diverted. Or maybe the water in the sea has also been diluted. Other causes could be overpopulation, just like in most of the developing countries you find whenever you have overpopulation, there is a lot of overexploitation of resources. You find there is deforestation. You also find pollution as one of the causes of reduction of mangroves. Now, the mangroves extends globally. You notice that Kenya has approximately 10,000 hectares of mangroves. The United States has approximately 100,000. India has at least 100,000 mangroves. And you notice in this diagram that shows the trends of mangrove extents over time in Kenya. There's a lot of data gaps. And that is one of the the problems that we'd like Venus to address. The current status of the situation at the moment in Kenya and other African countries is that there is lack of comprehensive information on the spatial extents of mangroves and vis-a-vis the species that exist in these areas. That's making it difficult to compare the trends in mangroves and also to find out information that could be useful for ecological mapping and developing management plans. Talking again on the issue of data availability, we look at all the African countries, and we notice that most African countries at the moment are relying on reference data, which could actually be gotten from remote, are relying on estimated data, which could be gotten from remote sensing, as compared to the reference data, which you notice is very, very small. Now, we are aware that for you to get accurate results with remote sensing, you need training data, you need reference data. So, one of the things that we would like to address in our discussion will be how to strike a balance between getting accurate data with less training data. Accurate data in remote sensing with less training data, less ground truth data. So one of the criteria, or some of the criteria that you can look at when you want to come up with habitat change parameters, that they should be repeatable, they should be representative. It's important for them to be, for it to be understandable. I mean, the criteria that you're going to assess for change, it should be understandable across the board. And the most important is that it should be cost effective. I would like to briefly talk about remote sensing because we're having a diverse audience. So maybe I'll introduce you to remote sensing, which is part of the concept that Venus is based on. Remote sensing is useful for the study because remote sensing gets multi-temporal data repeatedly over study areas without studying the steady areas. Now, how the remote sensing operates is, the idea behind remote sensing is that you get solar energy from the sun. It is either absorbed, transmitted, or reflected by an object. It goes back when it's reflected to the Venus sensor. Then it can be received at the receiving station. You can also get coordinates of the point using GPS. You can process the data, and it can be useful for information. Some of the other concepts that you can use in line with the remote sensing is NDVI, that is to differentiate vegetative features. And NDVI is basically the difference between the near-infrared and the visible spectrum, which is normalized, divided by the sum of the near-infrared and the visible spectrum. And here I show you the spectral reflectance of vegetation. Now, when you have to study different species, of course you expect different curves of spectral reflectances. And if this can be captured by the sensor, then it becomes useful for the study. Now, Venus mission. Actually, Venus has come up with a satellite that is has been developed by the Israel Space Agency and the French agency National d'Etudes. Well, I think you helped me read that, which is very, very much known for producing very quality products in line with remote sensing. The beauty of this Venus mission is that it will have 2 days data with observation angles constant. It will have 12 narrow bands. It is free. It can have a spatial resolution of 5.3 meters at nadir. Some of the ideas that we are going to use, for example, the NDVI can be adequately used with the Venus sensors. You can easily use red and near-infrared bands. You can also have atmospheric correction using the blue bands. The research questions that we intend to address in this study is if Venus can be used to find out the spatial extent and the conditions of the mangrove forest, whether it's possible for Venus to distinguish the various mangrove species, and whether it's possible to devise a technique that can continuously update or map the changing extents of mangrove forests in my study area. In line with the research questions, we developed the following objectives. And one of them was to demonstrate the potential of the Venus satellite to discriminate various mangrove species, to test whether the decision tree could be used, to create detailed maps, to find out the spatial extents of the mangroves, and of course to provide recommendations for sustainable management. Now, the study area is in Kenya. To be specific, it's somewhere to the south of Kenya, here, and it extends 18 kilometers squared, and you notice that 18 kilometers squared can fit the size of Venus, which is 27 times 27 kilometers squared. The methodology that we intend to use is, of course, decision trees, but first of all, I'll introduce you to the concepts of classification. Classification is all about getting spectral signatures of objects that have been sensed by a satellite and grouping them together so that you can be able to interpret the features that you have in the ground. There are different ways of getting classification. One is the neural nets, which use weighted layers of the spectral signature. Another one is the nearest neighbor. And the trees, which we are going to use in this study. Why do we decide to use trees? Now, trees are important because you can put up some sort of logic to get your results, and you can as well work backwards. And you don't also need to make any assumptions regarding linearity of data, unlike the normal max-like classification, which uses, you must have a normal distribution. And trees can also show hierarchical relationships, which are important for for the engineer. You can easily track where you got your mistake.